Hi, welcome to our group's presentation for our physics investigation. The topic that's issued to us is wireless power transfer. I'll be the first person giving introduction on what wireless power transfer is all about. And the rest of my teammates will talk in further on wireless power transfer. As the word wireless means without wire, transmission of electrical power through the air from a power source to a consuming device without using solid wires or conductors. A transmitter device connected to a power source, such as the main power line, transmits power by electromagnetic fields across an intervening space to one or more receiver devices, where it is converted back to electrical power and utilized. There are 5 methods of wire power transfer, but for the sake of this experiment on its own, we are focusing on inductive coupling. What is inductive coupling? Inductive coupling is an intelligence enough to manage varying loads on its secondary coil, allows a configuration where conduction is most efficient. Visteons, a company, has used this technology to create a charging drawer inside the car for portable rechargeable devices. What are the advantages of wireless power transfer? Well, one thing, you don't have to use wires. It's high efficiency, highly efficient mean, low maintain cost. Disadvantage technologies are known, may damage to our health. Its initial cost is high, and the current technology only allows transmission across small distances.
Inductive charging is the most popular form of wireless charging for mobile devices, and leading the way is the Wireless Power Consortium with their Qi Open Interface Standard. Using fundamentally the same technology, other groups are incorporating inductive charging tech for use in electric vehicles. Getting to the bottom of inductive charging, we have to go all the way back to the mid-1800s, when Michael Faraday discovered the underlying principles of electromagnetic induction. He discovered that in the presence of an alternating magnetic field, an electromotive force would be produced across an electric conductor. By the late 1800s, Nikola Tesla utilized this idea and demonstrated the phenomenon of resonant inductive coupling by lighting an incandescent lamp wirelessly. By tuning the current to match the resonant frequency of the coils, the two coils would couple, providing higher efficiency of power transfer. The discoveries that stem from Faraday's led to the modern electrical motor and unmeasurably important inventions. However, for inductive charging, the science proved easier than implementation. For starters, there weren't many electronics that would greatly benefit from such technologies in the days of Nikola Tesla, and due to limitations in circuit board design and size constraints, it wasn't until the 1990s and 2000s that the technology became viable at the consumer electronic level, where we started seeing wireless charging toothbrushes and in 2008 wireless charging mobile phones. An inductive charger consists of only a few parts: AC current from the wall, an oscillator electrical circuit, and the transmission coil. The transmission coil is a tightly wound copper element that, as the alternating current passes through, would produce a magnetic flux. The magnetic flux density is based on things like the number of turns of the wire, the diameter of the transmission coil, the distance from the coil, and other properties such as current. On the receiver's end, the process is basically the same, except opposite. In the receiver device, a coil of the same type is embedded into the charging circuit. The alternating magnetic field is picked up by the receiving coil, and a current is induced. The AC power is passed through a power rectifier and stabilizer to convert it into DC power the phone can use to charge the battery. The transmitter and the receiver have electrical resonance frequencies designed to be the same. For low displacement distances such as mobile phone on a charging pad, it is actually less efficient to operate at the circuit resonant frequency due to heat generation. However, for a larger displacement distance, such as a car parked over a charging pad, operating at the resonant frequency causes inductive coupling to counteract some of the displacement-related transmission losses. But there are many other factors that affect performance of transmission, and with no standardized design on the phones and yet, charging ports need ways of detecting the type of device it is charging, having multiple coil arrangements, and control modules to alternate between modes.
Electric vehicles are becoming more popular due to concerns about the environment and rising of gasoline price. We can either charge the vehicle by using wired or wireless method. However, the wireless charging infrastructure was lacking earlier but is growing now. The current system is only allowed for stationary charging and the amount of time required is quite high. Therefore, the system does not satisfy the user effectively. This is the most common method that we use to charge our electric vehicle. Physical plug is hassle because it requires user to plug in routinely and there are a number of occasions when the owner could very well forget to charge the vehicle. The other disadvantage is the power will lost during transmission of electricity. According to a research, there are approximately 26% of power loss during transmission of electricity, and this is due to the resistance of the wire. With stationary wireless charging, the user can simply plug the vehicle over a charging pad on the floor and a corresponding charging pad mounted on the other side of the vehicle picks up the signal and charges the vehicle. This is the sample image for existing system. As you can see, the charging pad can be embedded under the ground and is convenient and safe. This system will not affected by weather such as rain or snow. And there is still 91% efficiency over a tenth inch of gap. Lastly, you don't need to park precisely under the charging pad. Just roughly position the car over the pad and it will start charging. What could be done in the future? It is dynamic charging. Dynamic charging means your vehicle could be charged wirelessly while in motion. As you can see, there's a special lane for typical vehicle that is electric car. Try to imagine that you can drive forever in that lane with non-stop because electricity in your car won't use up as it continues charging forever. That's enough for cars. Now let's talk about our lifestyle.
Do you hate wires without reason? Do you struggle when you can't place your electrical furniture at the place you want it because the socket is out of reach? Are you sick of those wires lying around you that trip you and make you roll like... So now your worries are gone with wireless power transfer furniture. As you can see from this pic, these furnitures no longer needs wires and plugs to do their work. You can place them anywhere you like as long as there is an electric field. You can even place a lamp on your head and bam, it just works. So here's a video about wireless power transfer of electricity.
This room can charge your phone the moment you walk in. Disney Research has successfully turned a room into a wireless charging station. Quasi-static cavity resonance is a method that induces electrical currents in an enclosed metallic structure. Power generated and amplified outside the room is picked up by a coil receiver inside the room, then transmitted to discrete capacitors inside a copper pole. The induced currents flow through the pole, ceiling, walls, and floor, generating an electromagnetic field. 10 devices were powered by the room simultaneously in this experiment. Researchers conducted the study according to federal safety guidelines and believe this method should cause no harm to the human brain or body.